Good morning to everyone. So only 3 people are there, right? So anyway, I will start. So today topic is carbon cycle. Okay. So now, what is carbon cycle? Right? So carbon, first one, carbon. What is carbon? Carbon is an element, right? So it is found throughout the universe, right? So carbon is virtually important molecule in the carbon cycle. Of course, it percentage is less compared to other gases, right? So it is found in all living things, and without carbon, there would be no life on Earth, right? So the characteristics of the remarkable carbon atom, it make possible the compounds that are necessary for life on Earth. So, and carbon is also a part of non-living things such as the oceans, rocks, right? And animal shells and the atmosphere, right? So now you see here, so what is carbon cycle? So this is 5 marks question. Okay. In your theory examination, they are asking. So circulation. You see here, circulation of carbon from atmosphere to biosphere to hydrosphere to lithosphere and return back to its atmosphere. So it's called carbon cycle. So what happened here? Carbon doesn't just stay in one place, right? So, however, it's always on the movement, right? So, carbon atoms continuously move through living things, the oceans, and the atmosphere, and the crust of the earth. So, this movement is as the known as carbon cycle, right? So, now, why carbon is important? Why? So because many elements, right? Many elements have cycle, right? So, but the cycling of carbon atoms is particularly important because through photosynthesis and respiration, it is the way the earth produces food and other renewable resources, right? So the carbon dioxide plays a key role in trapping heat in the atmosphere and one of the basic mechanisms behind the greenhouse effect. So the carbon plays a central role in combustion. So through decomposition, and it serves as the earth waste disposal system also. In addition, the carbon cycle is important because carbon containing gases in the atmosphere affect the earth's climate, right? So the increased carbon dioxide in the atmosphere, it has been responsible for more than half of the climate warming observed in recent decades, right? So now you see, next slide is, so a carbon dioxide molecule is made up of one part of carbon, this one, okay? One part of carbon and two parts of, what is that? Two parts of oxygen. It's called carbon dioxide, CO2, right? So, from the atmosphere, the carbon dioxide enters into the plants through which one? Photosynthesis to synthesize food particles, right? So, now what is photosynthesis? So, all of you know about this in your small age classes. You are already learned about this. So, because we are read in previous, not previous, in school level, we are reading that, right? So, photosynthesis. So, photosynthesis means photo, right? Photo. Photo means, what is that? Light. Okay. Photo means light. Okay. Light. And synthesis means putting together. Okay. Putting together. Okay. So photos means light and synthesis means putting together. So photos and synthesis, these two words are Greek words. Okay. These are Greek words. So photosynthesis is the process by which the plants or leaves prepare or make their own food using carbon dioxide and water and sunlight. So in the absence of sunlight, a plant cannot prepare its, what is that? Its own food, right? So during this photosynthesis, carbon dioxide is taken into the plant and changed into the plant food, right? So the carbon is then stored in this food. So you see this picture. Okay, right. So when you see here these green plants, right? You see here, these are the plants, right? So these green plants undergo the uh, process. Just wait. This process of photosynthesis to make uh, food, right? Make food. They absorb carbon dioxide from the air. Okay. So plant, they fix the carbon dioxide in the process of which one? Photosynthesis. This photosynthesis. And it is made to carbohydrates and proteins and also other kind of organic compounds such as glucose. Right? So this is the photosynthesis. Now, next one is how do carbon dioxide enter into the animals? How? You see here. So the carbon dioxide enter into terrestrial organisms when the plants are eaten by them, right? When the plants are eaten by them. So the carbon elements stored in plants is then transferred to the animals when those are eating the plants, right? So what happened here? The plants are eaten by the animals. You see this carbon dioxide, right? So they are eating this one, okay, like this. So eaten by the animals. So the carbon transfer to the organic compounds of the animals, right? So the carbon dioxide enter through this process, okay, to animals, to the. So now, how do carbon dioxide enter into the soil? So up to here, how to enter the animals. And next one is how to enter into the soil carbon dioxide, right? So now you see here this picture. When these are organisms die, carbon dioxide, what happens is that carbon dioxide enters into the soil. How? How? Okay, right. So when a huge amount of trees got buried under the soil by the earthquakes or some other reasons, it forms, what is that? It forms coal, okay? Coal. What is that? When huge amount of trees got buried under the soil by the some other reasons or some earthquakes, it forms coal, right? So coal is a large deposit of forest under the absence of air and high temperatures. So it forms coal, right? So certain carbon is trapped in the form of coal in the ground, right? So even certain animals, when got buried under the layer of soil, they form petroleum also, right? They form petroleum. What is that? What is the coal and petroleum? So coal is large deposit of forest under the absence of air in high temperature. So it forms coal. But petroleum, even certain animals which got buried under the layer of soil and they form the petroleum, right? So the organic compounds that are formed from the air, right? So by which one? Photosynthesis from plants and from the plants to the animals. So these organic compounds, when they got buried in the soil, they form the fossil fuels like petroleum and coal, right? So got the point? Okay. So whatever the fossil fuels were burning, right? So now using for other various uses, all these fossil fuels are the carbon compounds. So petroleum is a carbon compound and coal is a carbon compound, right? So when the plants and animals are die, what happens there? Their dead bodies are released the carbon dioxide into the water, right? Sorry, into the soil, right? So when the plants and animals are dying, what happens there? Their dead bodies are released the carbon dioxide into the soil or ground, right? So now, next one is how to carbon dioxide into the water, how to enter, right? So I already told about photosynthesis. So when carbon dioxide enter into the water as carbonates, right? Carbonates. So which are helpful for this aquatic plants to perform photosynthesis. Okay, to perform photosynthesis. So the carbon dioxide which dissolves in the water, it falls carbonates in the water, right? Next one is limestone. So what is this limestone? So limestone also in the rocks, the carbon is also available as limestone. Limestone means CaCO3, right? So, and even a greater amount of a carbon that is stored for millions of years is incorporated into the shells of this marine organisms, right? So when those animals are any, so that when those organisms are die, their shells sink to the ocean floor and sediments cover them with the forming and cemented together to form this limestone. Okay. So the organic compounds in the animals in certain carbon animals. So the shells are made up of carbonates. So that is calcium carbonate, right? So in the living organisms, in animals, how the carbon is there? So that is animal bodies, even bones, right? So now what is your bone made up of? What is your bone? It's made up of what? Right. So bone is a salt of calcium, right? So, and it is a salt of carbon and carbonate salts. So that is calcium carbonate and calcium phosphate, right? So your bone, and our bones are packed with what is that? Carbon, right? So your cells are made up of carbon compounds like proteins, lipids, and also carbohydrates, right? So the carbon compounds are the organic compounds. They form the organic compounds in the bodies of the animals and plants, right? So got it? Now, how carbon dioxide to enter, or sorry, up to here, we discussed only how to enter carbon dioxide into the animals and plants and soil and water, right? Now, how carbon dioxide to return back to the atmosphere. How? You see here. Remember, up to here, how to enter the carbon dioxide, and how next step is how to carbon dioxide return back to the atmosphere. So I already told this one, na? This one. So what is that carbon cycle? So carbon from atmosphere to biosphere and to hydrosphere and lithosphere, and return back to atmosphere. Okay. So how? How means you see here. Okay. So now we'll learn about how carbon dioxide returns to the atmosphere through from fossil fuels, and from respiration of animals and combustion or burning of woods, and from motor vehicles, and from cement manufacturing and so many industries, and also deforestation. So these are the very important things, right? So from motor vehicles and so many industries has released as smoke, right? So that is also very important. So now we are going to one by one. First one is from fossil fuels. How to carbon dioxide return to atmosphere from fossil fuels. You see here this figure. So when those plants or animals, they die, they decompose, right? They decompose. So then they get composed the carbohydrates and other compounds, and carbon dioxide is released into the atmosphere, right? So, and here the carbon is moved through decomposition, right? So that is because when plants and animals are die, their bodies, what happens? Decay, and carbon dioxide is released into the air or atmosphere, and carbon moves back into the air, right? So this is from fossil fuels, and from respiration of animals. So carbon dioxide on the move through which one? Respiration. Respiration means what is that? Breathing, right? So during respiration, the animals take in oxygen and breathe out carbon dioxide, right? Breathe out carbon dioxide like this. Okay. So wherever these organisms, even though they are living, they carry out respiration in their bodies, right? So they are released the carbon dioxide out. So carbon dioxide is released by the plants and animals when they are living, right? When they are died. So when their bodies is decomposed, the carbon dioxide from the plants and animals escapes into the atmosphere, right? So in this way, they reaches back into the atmosphere. So you remember in the photosynthesis and respiration, right? So photosynthesis and respiration are essentially the opposite of each other. Remember this word. So this photosynthesis and this respiration. So these are essentially the opposite of each other. Okay? Opposite of each other. So the photosynthesis removes carbon dioxide from the atmosphere and replace it with oxygen, right? But respiration means it takes oxygen from the atmosphere and replaces it with carbon dioxide, right? So you got it? So photosynthesis. Right, photosynthesis, right? This photosynthesis removes, right? Removes carbon dioxide from the atmosphere, right? And replace it what? Oxygen. So this is the photosynthesis process. But in respiration, it takes oxygen from atmosphere and replace it with carbon dioxide, right? Replace it with carbon dioxide. So opposite one, right? Opposite. So however, these processes are not in balance, right? So that is respiration and photosynthesis. Don't confuse that. Okay. Next one is from burning of wood or combustion, right? So now, so the process of burning or combustion may return the carbon dioxide in oil, coal, natural gas, and wood to the atmosphere, right? So in combustion, organic molecules are rapidly oxidized. Oxidized means combined with oxygen, right? And converted to carbon dioxide and water with release of light and heat, right? So you see here, the burning wood release carbon stored over the previous decades in one peak burst. So for an equal amount of heat or electricity, it released, what is that? More carbon dioxide than burning gas, oil, and even coal. So straight away, we have more carbon dioxide in the air from burning wood, right? Burning wood. So this should be reabsorbed as trees regrow, right? So this one. And next one is, so from motor vehicles, how to carbon dioxide into the atmosphere from motor vehicles. You see here, the modern transportation. Nowadays, the modern transportation relies heavily on petroleum and passenger cars and light duty trucks, right? So those are contribute half of the carbon dioxide emissions from the some in US transportation sector, right? So or in India also. So burning 1 gallon of gasoline creates about how much? 20 pounds of carbon dioxide, right? So which means the average vehicle creates roughly how much? 60 to 9 tons of carbon dioxide in each year. Okay. So a typical passenger vehicle emits about how much? 4.6 metric tons. 4.6 metric tons of carbon dioxide per year, right? So this assumes the average gasoline vehicle on the road today, it has a fuel economy of about 22 miles per gallon and drives around 11,500 miles per year. So every gallon of gasoline burned creates about how much? 8,887 grams of carbon dioxide, right? So this one, and so from cement manufacturing factories or some, oh, places. So in cement manufacturing, right? So there are two major sources of carbon dioxide emissions. So the first one is the primary source. What is that? 60%, right? 60% of total emissions. So that is the calcination of limestone, CaCO3, right? CaCO3. So limestone, when heated to about 900 degrees, right? 900 degrees Celsius, it converts to thick lime. It means CaO. That is released carbon dioxide. Okay? That is released carbon dioxide. So the cement is an important construction ingredient produced in virtually all countries, right? So the carbon dioxide is a byproduct of chemical conversion process used in the production of clinkers, a component of cement in which limestone means CaCO3. So that is converted to lime, CaO, right? And that is released the carbon dioxide, right? So now deforestation. So deforestation means, all of you know, so cutting down trees, right? So the deforestation, the trees and other plants absorb carbon dioxide from the atmosphere as they grow. So this is converted into carbon and stored in the plant's branches and leaves and trunks and also roots and in the soil. So when forests are cleared or burned, and store carbon is released into the atmosphere, mainly carbon dioxide, right? So now in this diagram, we see the exchange of the gases, right? Exchange, you see here, exchange of the gases. So the carbon dioxide and oxygen between the plants and animals, right? So all of you listen carefully. So everyone or everybody should plant some plants in your house. At least one plant you can plant. Okay? So this is my request. So now this topic is over. Just wait, I will upload another PPT. So any doubts in this lesson in carbon cycle? So this is 5 marks question. So what is carbon cycle and how to um, carbon entered into some animals and plants and water, right? And return back, how to return back carbon dioxide, some fossil fuels, deforestation, uh, combustion, etc., etc., right? So this is the carbon cycle. So this is 5 marks question. Okay. So any doubts in this? Only 3 people are there. So anyway, just wait. Right. . So now next lesson or next topic is what are the solutions of global warming? So this is also general topic. So you can write in general in your theory examination, right? So now right. So what are the solutions? Right. So the global climate change is certainly one of the top environmental issues nowadays, right? So the global warming, sorry. So global warming is a dangerous effect on our environment, right? So that we are facing these days. So increase in the population growth, pollution, and rapid industrialization. So these are causing a rise in global warming. So the global warming refers to increase in the average temperature of the Earth's surface during the last century, right? So the global warming is a gradual process of heating and rising temperatures in the Earth's surface and atmosphere, including oceans and ice caps, etc. Right? So the causes are these are many causes is there, right? Of global warming. So some are some are what is that natural and some are man-made causes is there, right? So the most important cause of global warming is greenhouse, right? Greenhouse gases. So which are generated some naturally and with human activities. So these are increased, right? So because of the increase in population and economy. So the release of carbon dioxide and chlorofluorocarbons and harmful gases in the atmosphere, which leads to rise in temperature, right? So the global warming has been accelerated due to mass deforestation activities by which one? Humans, right? So burning of fossil fuels, using lot of vehicles and cutting down trees, etc. So these are the major causes behind global warming, right? So another major cause of global warming is depletion of ozone layer. So that is a big topic in next um, class or next PPT. Okay. So the ozone layer causes protection to the earth surface. So in inhibiting the harmful sun rays coming to the earth, right? So it is depleting due to what is that excess release of fluorocarbon gas and global warming. So that harmful ultraviolet sun rays enter into the biosphere, it causing more temperature and more global warming, right? So there are many causes, right? There are many causes of global warming. That warming is a danger for the existence of life on the earth. So that most evident causes of global warming are industrialization, deforestation, and sophisticated human activities, right? So these human activities have led to an increase in emission of the greenhouse gases and resulting of this the temperature increasing the melting glaciers also, right? So in fact, the average temperature of the planet has increased by how much? zero point 0.8, right? 0.8 degrees Celsius for or 33.4 Fahrenheit, right? And it compared to the end of the 19th century. So each of the last 3 decades, it has been warmer than all previous decades since the beginning of the statistical survey in 18, right? 1850, right? So, at the pace of current carbon dioxide emissions, the scientists expert an increase of between how much this one 1.5 degree and 5.3 degrees Celsius, or 34.7 degrees to 41.5 degree Fahrenheit in average temperature by in which year 2100 year, right? How much? 1.5 degrees to 5.3 degrees, right? So if no action is taken, what happen? It would have harmful consequences to humanity and also biosphere, right? So when the heat trapping greenhouse gases are increasing, and what is happening? So automatically global temperature is rising, and earth is warming, and glaciers are melting, and also sea level is rising, right? So this weather change is drastically affecting wildlife and forest. So yes, right? Is this weather change is drastically affecting wildlife and forest? Yes, yes. So global warming is happening due to the greenhouse effect. Some of the contributing factors are burning of fossil fuels, deforestation, etc., etc. Right? So burning of fossil fuels such as natural gas, I already told about this, right? So the consequently, it leads to drought and incessant rainfall and hurricanes and extreme heat waves and also other extreme weather conditions. So with these adverse effects of global warming happening across the planet, we need to implement ways to stop global warming and protect the plant. So now, so now, what are the consequences? What are the consequences of global warming? So consequently, it leads to temperature on Earth increase and heat waves, droughts, and sea level rise. That is due to melting ice sheets and glaciers and climate change, and also changes in precipitation pattern and emissions of greenhouse gases and sorry, excuse me, and habitat deforestation of animals in Arctic region and coral bleaching, and also crop crop failures and food security get affected, and environmental mitigation and floods and storms and also air pollution and loss of biodiversity and hurricanes in tornadoes and risk of human health and desertification and loss of fresh water and cyclones, higher death rates and petty invasions, water shortage and wildfires, stress on ecosystem and gross domestic products, right? Product loss, that is called GDP, and disruption in production of energy, and also damage on property and infrastructures, right? So these are the consequences. Now here are some simple actions we can take to help reduce global warming, right? So now recycle. So what is the recycle and more? So this aim is to cut down the amount of carbon dioxide released into the environment, right? So if you even recycle half of the waste produced at home, you can save up to how much? 2,000 pounds of or 1 ton, right? 1 ton carbon dioxide for every year, right? Every year. Okay. And next one is drive less. So the air pollution is one of the major factors that leads to an increase in greenhouse gases, right? So minimize the use of cars and make use of public transportation, right? So try to walking and biking. So these are the great forms of exercise or carpooling whenever possible, right? So even vacations can provide opportunities to reduce your carbon footprint, right? So if you reduce the driving hours, what will happen? You will end up saving 454, right? 454 grams of carbon dioxide every mile, not every year, every mile. Okay, 454 grams. Okay, so that's why you can save 454 grams. Okay, when you are using walking, biking, and great forms of exercise or carpooling, right? So now switch to renewable energy. So one of the most effective ways to prevent global warming is to start using renewable energy source such as the solar, right? Solar and geothermal and also this wind and biomass, and stop using fossil fuels. So use renewable energy resource to supply power to your home. Okay. And next one is use energy efficient devices. So what is the energy efficient devices? How to use and how to stop and how to use less. Okay. And by investing in energy efficient devices such as bulbs and LED bulbs, right? Or a solar powered shower system. So you can reduce the energy consumption and help in the production of clean energy. And it is not only the cheapest way to reduce greenhouse gas emissions, but it also reduce the amount of carbon dioxide released into the atmosphere. So avoid some products that come with excess packaging, especially molded plastic and packaging that cannot be recycled, right? So if you reduce your household garbage by 10%, you can save how much? How much? 1,200 pounds of carbon dioxide per year, right? So now use less hot water. So do you know you can save 50 grams, right? 50 grams or 500 pounds of carbon dioxide per year if you switch to cold shower, right? Not hot water. If you switch to cold showers and stop using hot water to wash clothes also, and try installing energy efficient geysers that consumes less energy, right? And then next one is a turn off some electronic devices. So ensure turning off your electronic devices such as television, computer, and also stereo music player when not in use, right? So this can help in saving fuel that is used to generate electricity, which in turn can reduce thousands tons of carbon dioxide released into the atmosphere. So save electricity and reduce global warming by turning off lights when you leave your room and using only as much light as you need. Okay. So and remember to turn off your television, video player, stereos, and also computer. So when you are not using them, right? So you can save the carbon dioxide. and spread awareness. So that is speak up about global warming, its consequences and causes, and what steps we can take to prevent global warming with your friends and family and colleagues, right? So use the power of social media to voice your out your concern about climate change, right? So this is a good one. Spread awareness, right? Next one is save water. So make sure to turn off taps while brushing, go for shorter showers, and do not waste water by cleaning your cars or bikes, etc. Right? So by following these easy tips, all of us can play a significant role in reducing carbon dioxide emission, right? And it preventing global warming, thus preserving the planet for future generations, right? So it's also a good idea to turn off the water when you are not using it. So while brushing your teeth and shampooing the dogs or washing your car, and turn off the water until you actually need it for rinsing. So you will reduce your water bill and help to conserve your vital resource, right? Next one is one child. One child means more humans means more greenhouse gas emissions, right? So one planet and one child. So that is good one. Okay. And next one is plant trees. So deforestation plays an important role in our global warming, right? And climate changes also. So the planting trees is helpful as they absorb carbon dioxide from atmosphere and regulate the climate. So hence there is a there need to plant more trees because a single tree can absorb how much? One 1 ton of carbon dioxide in its lifetime, not year, its lifetime, right? So the trees can be quick solution to combat climate change, but each year we destroyed 30, right? 30 million acres of forest and destroying the biodiversity of these amazing ecosystems, right? So we can buy recycled paper and use it several times. We can buy only certified wood and we can plant more new trees, right? So plant a tree, start digging, and during photosynthesis, trees and other plants absorb carbon dioxide and give off oxygen, right? So these are the solutions of global warming. Okay. So sometimes they are asking how to stop the global warming, right? So what are the solutions? So you can write these things. So and recycle and switch to renewable energy and use energy efficiency and use less hot water and turn off electric devices and spread awareness, save water, one child, plant trees. So you can write these, explain about these, okay? So now just wait, I will upload another PPT. Okay. So any doubts in this PPT?
Ma'am, good morning, madam.
Good morning. Good morning.
Ma'am, this previous like a question paper, like to get us some sample or some idea about how to we can like expect the question, where we can get like this, ma'am.
Sorry, I can't understand your question. So your voice
Yeah,
is low.
yeah, like a previous question paper, ma'am, like
Yeah,
to
yeah,
get
I
a,
will upload. I will upload. So you are from
I am actually I'm from Andhra Pradesh, ma'am.
Acha, AP. Okay. So you are in a WhatsApp group? In a
Ma'am, and unfortunately, I'm not in WhatsApp group, ma'am. Last time also I asked the Andhra madam, but unfortunately, I am not in WhatsApp group. How to get
so okay. So your center is only Hyderabad, right?
Yeah, my center is Warangal, ma'am.
Warangal, okay. So tell me your number, I will add you.
Ma'am, my number is 00
Uh, 00
971
971
56
56
866
866
03
03. So
73.
what is this?
Ma'am,
Your admission number, this one?
admission number of ma'am. Actually, I'm from Andhra Pradesh, but I'm working in Dubai, ma'am.
Acha, okay, you are working in
Uh,
Dubai. Okay, right.
that's why
Oh,
my admission number is 021
not necessary. Tell me again your mobile number.
00971
Right.
56
Ah,
866
yes.
03
Okay.
73
7
373.
7 3. So what is your
Yeah,
name?
Gauss Basha.
Gauss Basha. Okay.
Yeah,
Okay. So I will add in our WhatsApp group. Okay.
please, ma'am.
Don't
Yeah,
worry. Okay.
yeah.
I will upload previous question papers
Okay,
with our WhatsApp. Okay. Don't.
okay, ma'am. Thank
Okay.
you, thank
Right.
you, ma'am.
Oh.
Ma'am, can we get your email ID or something, ma'am, to something if any
My
doubt or
email ID.
yeah, ma'am.
Yeah. Dr. Sanda Rajita. DRSANDA.
Yeah, wait, just wait, ma'am. DR
DRSANDA.
SANDA.
DA Sanda, SANDA, Sanda Rajita, RAJITHA. So you see my name in our participant group in the Zoom, Dr. Sanda Rajita
Yeah, yeah,
@gmail.com. Okay?
Rajita at gmail.com, right?
Gmail.com. Okay?
Okay,
Okay.
okay, thank you, ma'am.
Okay. Just 1 second. Right. So now next topic is layers of the atmosphere. Okay? So the atmosphere has how many layers? 5 primary layers. So before going into main topic, we start from the earth, right? So the earth is third planet from the sun, right? So the a distance from the sun is how much? 149, right? 149,600,000 kilometers, right? 149,600 kilometers, right? So remember the distance from the earth to the sun is called an astronomical unit. It's called AU, right? AU, astronomical unit. So, which is used to measure distances throughout the solar system, right? So, the Earth is only the planet known to have an atmosphere containing free oxygen, oceans of liquid water on its surface, and of course, life roughly 70% of Earth surface is covered by water, and most of it in the oceans, and 30% of the Earth surface is land, right? So now let's understand the layers of atmosphere. The atmosphere layers an important role in making life possible on Earth by protecting our Earth from harmful ultraviolet radiations of sun. So the atmosphere of Earth is the layer of gases commonly known as air. So that surrounds the planet of Earth and is retained by Earth's gravity, right? So now you see in this figure, it shows how temperature changes with height in our atmosphere. Temperature profile is represented in this red line, right? This red line. Okay. So the x-axis, right? X-axis is temperature in degrees Celsius every 20 degrees from minus 100 plus 20, right? So you see here, this one. So, and y-axis is height, right? Y-axis is height and kilometers, and the increment is 20 kilometers, as you can see. So, the first layer of the atmosphere is, what is that? This one, troposphere. Okay, troposphere. So almost all weather that is of importance for us takes place in the troposphere, storms and clouds, hurricanes, precipitation. So that is all in the this troposphere, right? So in troposphere, temperature decreases linearly with height, and linearly means a straight line, right? Straight line. So the average temperature around the globe, the sea level is also decreasing 15 degrees, right? 15 degrees Celsius. So the troposphere is about 11 kilometers, right? This one, right? 11 kilometers height, and the temperature at those altitude is minus 56, right? Minus 56 degrees Celsius. So in this layer, the temperature decreases with the height because atmosphere is predominantly heated by the surface, right? So the further we are from the surface, the colder it gets. The top of the troposphere is called tropopause. This one, right? Tropopause. This tropopause. Okay. So now that troposphere is 11 kilometers deep, but that is not everywhere around the world. So the depth of the troposphere is around how much? Only 9 kilometers in the polar region. Remember, polar region, and around 17 kilometers in the tropical region, right? So in polar region is 9 kilometers and tropical region is 17 kilometers. So this has to do with the fact that pressure decreases faster in cold air than in warm air. So you will remember that we said, let's assume these are two pressure surfaces. So they are further apart if the air between them is warm, then they are, if the air between them is cold, and that's why troposphere is deeper in uh, tropics then. So it is in the polar regions, right? And then the next layer is troposphere, second one, right? Troposphere. So, and this layer is between approximately 11 kilometers, right? 11 kilometers and 47 kilometers above surface, right? This one surface of the top of this layer is stratos pause here, this one, okay? So now here the temperature does not decrease with the height. Instead, temperature is first fairly constant, and then it is actually increasing with the height temperature. It tends to, as we can see, overall increase with the height, right? This one in the stratosphere. So because of ozone that absorb, right? Ozone that absorbs ultraviolet light and protects. So all us living creates from harmful impacts of ultraviolet radiation. So the highest concentration of ozone is between 15, right? 15 and 30 kilometers above the surface, right? So now it is interesting to note that while all light aircrafts, right, aircrafts fly in this troposphere, like those that spray some chemicals to kill mosquitoes. So the commercial aircrafts tend to fly in stratosphere, in the lower stratosphere, and military airplanes can reach even higher altitude for example, SR, right? SR-71 Blackbird flies at 25.9 kilometer in the stratosphere, right? That is named SR-71 Blackbird, right? So that is military aeroplane. And also Russian Sukhoi, that is SU. Its name is SU-57 flies. SU-57 flies at 20.1 or 20 kilometers above the surface. However, these aircrafts are overpowered by weather balloons, so that can reach 39 to 40 kilometers above Earth's surface before they explode. Right? And troposphere is over and stratosphere is over. And next one is third layer, right? Third layer is mesosphere, and next layer is thermosphere, and fifth one is exosphere, right? So now you see here, there are 5 major layers in the structure of this atmosphere, depending upon what criteria? Temperature variation criteria, right? So first of all, we learn temperature variations here. I already told about this red color is increasing temperature from sphere to sphere, right? So the mesosphere, next one, mesosphere. What happened in mesopause? This is called mesopause, right? So it is the transition zone between where mesosphere and thermosphere. So it's called mesopause. So again here, sometimes it remains constant. It means it is 2 degrees Celsius. And then again it goes on increasing 82 from here. You see here, this one, this line, yellow, right? 82 degrees Celsius to 1200 or above, right? And further, when we go to the exosphere, we find the differences, right? So what we see is this sigma, right? This one, sigma. The sigma kind of situation in the diagram, if you see, observe this one. So in this the simple diagram, we can remember this looks like sigma symbol right from the troposphere to exosphere and the outer sphere. So how does this isotherm look like this sigma line, which we say this looks like a sigma, right? So what happened here? There is a change in temperature across all these layers, right? All these um, 5 layers, right? So with attitudinal factor, that is where the structuralization of the atmosphere is important, right? So on the basis of this temperature, so that is where we say those 5 layer structure are the stratified structure of the atmosphere, right? So you see one by one in detail. So troposphere, this is the first layer, right? First layer of the uh, atmosphere, right? So tropos means um, change, right? Tropo means change. Okay, change. So it is the first layer of the atmosphere from the earth, right? So it is also the one where we all live in it. So this layer gets its name from the weather that is constantly changing and mixing of the gases in this part of our atmosphere. So this layer is the lowest and closest to the earth surface, and average the troposphere extends from the ground to about how many kilometers? You see here, this one, 12 kilometers. 12 kilometers or 7.5 miles or 33,000 feet above the sea level, right? So the air never static in this layer. So it means in this layer, there is a lots of changes happening. So that's why it is also called changing sphere, right? Changing sphere. So the troposphere is a dynamic sphere where lots of changes are happening. So in this layer, where lots of atmospheric phenomena keeps happening with. So all weather conditions changes. It occur in this particular troposphere layer. So most of the clouds, right? Most of these clouds, you see this one, these clouds, right? Most of the clouds appear in this troposphere mainly because because of 99% of water vapor in the atmosphere is found in this troposphere only, right? So the troposphere contains about 75% of all the air in the atmosphere and almost all of the water vapor which forms clouds and the rain that we should understand, right? So in this layer, so air is made up of approximately how much? You see here 78%. 78% of nitrogen and 21% of oxygen and 1% of other gases, including argon and water vapor and also carbon dioxide. And apart from that we observed here, what is happening? The temperature decreases as you see in this graph, right? So the temperature decreases at the rate of 1 degree Celsius for every 165 meters. And so many people also write it into 6.5 degrees Celsius per 1000 meters. So that is for 1 kilometer. So it is an average value. So you can take either of them, that's okay. So that is also known as lapse rate. It's called lapse rate. So now remember, there is a temperature decrease with the increase in attitude in troposphere, and this is also called the normal lapse rate or environmental lapse rate, it's called ELP, right? Sorry, ELR, environmental lapse rate. Okay, so this is the troposphere. And second one is stratosphere. Tropo means changing, and strato means layer. Strat means layer. Okay, strat means layer. So this layer, this one, okay, this one, this blue color. Strat means layer. So this layer of our atmosphere has its own set of layers. So the boundary, you see here, the boundary between the stratosphere and the troposphere is called tropopause, right? Tropopause. This tropopause. And the troposphere is called the tropopause. So it is the region where aeroplanes fly. Aeroplanes fly. So because this less what is that? Turbulence, right? Turbulent layer provides a smoother ride. Smoother ride. So the jet streams flow near the border between the troposphere and the stratosphere. So the lower boundary of the stratosphere is called tropopause, right? So the stratosphere layer extends from the tropopause to about how many kilometers? 50 kilometers or 31 miles above the, which one? Earth surface, not troposphere, above the Earth surface only. Okay. So this layer contains a thin layer of ozone molecules, which forms a protective layer and absorb harmful ultraviolet radiation from the sun. It converting the UV energy into heat, right? So this layer is very dry as it contains little water vapor. It means the water vapor content is less there, right? So the stratosphere actually gets warmer the higher the trend of rising temperatures with attitude. That means air in the stratosphere lacks the turbulence and updraft of the troposphere beneath, right? So the high altitude weather balloons flying into the stratosphere for monitoring atmospheric conditions and climate research, right? So air is roughly 1,000 times thinner at the top of the troposphere than it is at sea level, right? Because of this, commercial passengers, jet flights and weather balloons reach their maximum operational altitude within the stratosphere, right? So in famous ozone layer is found within this stratosphere, right? So in the atmospheric ozone exists in two forms, that is good ozone is there and bad ozone is there, right? Good and bad ozone is there. So bad ozone means bad ozone formed in the atmosphere that is harms plants and animals, right? So good ozone protect us against dangerous UV light from the sun, right? So good ozone is found in the upper part of the atmosphere, that is stratosphere, right? And it acts as a shield absorbing ultraviolet radiation from the sun. So the ultraviolet rays are highly injurious to living organisms since DNA and proteins of living organisms preferentially absorb UV rays, and it high energy breaks the chemical bonds within the these molecules, right? So now the thickness of the ozone in a column of air from the ground to the top of atmosphere is measured in terms of what is that? Dobson units. Dobson units DU. It's called DU, right? So this is stratosphere. And next one is mesosphere. So meso means middle. Meso means middle. Okay, middle. This sphere. Okay, mesosphere. So this layer is located above the stratosphere and below the thermosphere, right? So it is the coolest layer of the entire atmosphere. Remember, coolest layer. Okay. So it is the third layer in our atmosphere, and its variation is how much? From 50 to 85 kilometers or 53 miles above in which place? Our planet. So by 80 kilometers, it reaches up to about minus 90 degrees Celsius temperature is there. So about 80 kilometer, it becomes now minus, right? So that is important. So that's why this layer is called coldest layer, right? So the air in the mesosphere is far too thin to breathe. Air pressure at the bottom of the layer is well below 1% of the at sea level and continuous dropping as you go higher, right? So, and most of the meteors, right? Meteors fall and burn up in this atmospheric layer, right? So, in now, the upper limit is called mesopause. This one, this red one, right? So I will tell you. And next one, thermosphere. This one, right? So thermo means heat, right? Heat. So this layer has extremely high temperatures and located above the mesosphere and below the exosphere. So the boundary between the mesosphere and thermosphere is called, what is that? This mesopause, right? This mesopause. So it is the coldest part of the atmosphere, mesopause. So the thermosphere extends from the mesopause to 700 kilometers. This one, 700 kilometers or 440 miles above the surface of the earth, right? So the thermosphere is the thickest layer in the atmosphere, and only the lightest gases and mostly oxygen, helium, and also hydrogen. So those are found in this layer also, right? So the thermosphere absorbed high energy X-rays and UV radiation from the sun and atoms turning them into ions with positive charges. Right? The temperature of the thermosphere varies between night and day and between the seasons as do the numbers of ions and electrons which are present in. So the ionosphere, this ionosphere reflects and absorbs radio waves, allowing, allowing us to receive shorter wave radio broadcast from the other parts of the world. So now you see here, the aurora and satellites mostly occur in this layer. Aurora, you see here these aurora and these satellites, okay? So aurora, what is aurora? Aurora means an aurora is a natural light, right? It displays in the sky. So particularly in the high latitude regions. So that is caused by the collision of energetic charged particles with atoms in the high altitude atmosphere, right? So this is where these charged particles or ionization happens, and that is where they flash off radiations in different kinds of color streams, right? So, and also the satellites for communication have been placed in this layer. So that we see here, right? So that is important, okay? And next layer is exosphere. So exo means outside, right? Outside. outside. So every layer it have meaning, right? So exo means outside. So exosphere, it represent the outermost layer of the Earth atmosphere, right? It extends from the top of the thermosphere at an altitude of about how much? 700, right? 700 kilometers above sea level to about 10,000 kilometers, where it merges into the solar wind above the Earth's surface, right? So this layer is mainly composed of extremely low densities of hydrogen, helium, and several heavier molecules, including nitrogen, oxygen, and also carbon dioxide, closer to the exoboss, right? So in this layer, the ozone, where atoms and molecules escapes into the space, that is mentioned as the exosphere, right? So the International Space Station, this one, right? The International Space Station orbit is also in this exosphere, right? So now, catalytic ozone creation and destruction. So when we say the natural ozone cycle, and what happened here, oxygen, and which is oxygen and reacts with ultraviolet light. So that is ultraviolet radiation. It breaks into, what is that? Oxygen plus oxygen, O plus O. So that is separated O and separated O, right? So O2 plus U equal to O plus O. So now this one separate, this oxygen, O plus O separate. So this one separate actually attaches itself to the oxygen, O2, O plus O2 attaches O2 and it becomes O3. It's called ozone, right? So which is what we commonly call ozone, right? So that is where this ultraviolet is important here. O plus O2 is called O3. So O3 plus ultraviolet again gives you one oxygen and one O2. So this is simple chemical equation. So what you observe is the role of this ultraviolet rays here, right? So in this second one, after introduction of this chlorofluorocarbons, and then if chlorofluorocarbons are there, then we see these ozone holes happening here, right? So why? Because you remember the chlorofluorocarbons react with this ultraviolet, and it forms different byproducts, that is chlorofluorocarbons and independent charged particles, that is ion species, the chlorine and others, right? So what we see is this chlorine, right? This chlorine plus O3 gives, now we see different kinds of molecule formations, right? So what happens? This ozone is actually broken by this particular chlorofluorocarbons. So the chlorofluorocarbons break this ozone. What we see, Cl plus O3 equal to ClO plus O2. So in this particular equation. So what happened when the ozone is broken? It means ozone concentration is now being destructed. So the formation and depletion are both important factors, right? Remember that. So if ozone is being destroyed, what will happen? So this ultraviolet, right? This ultraviolet factor, which used to be neutralized here, right? So this ultraviolet factor which was earlier neutralized by ozone, is now actually coming to the ground. So, and that where ultraviolet radiation is harmful for our human being and animal life as well on Earth surface, right? So, this is the whole idea of ozone depletion. It will come in next class briefly, right? So, it's over. So, this is the layers of the atmosphere. Okay. This is also very important questions. You're asking in your examination. So describe the layers of the atmosphere, or what are the layers in atmosphere, or types of the layers of the atmosphere, right? So this is 15 marks question in your examination asking. Okay. So any doubts in this topic, ask me really. I can stop now. So any questions, any doubts?
No, ma'am. Thank you so much.
Okay, right. So I will upload, don't worry, I will upload this PPTs, whatever I already told about these classes, right? Okay. So next class will start 11:45 maybe, 11:30. Okay. So Vasanthi madam will take the class. So now I will close this session.
Ma'am, kindly add me in the group, ma'am.
Yeah. Sure.
Okay.
Okay. I will.
Yeah.
Okay.